vertex form, to standard form. Standard form is the form that we've been looking at when we were doing factoring. That's the one that's ax squared plus bx plus c. Or you could say equals y. So in standard form, we have no parentheses, so that would be our first task, would be to get rid of those parentheses. Now, the good news is that when you're doing this, it's all just a bunch of multiplying and combining like terms. So the first thing we've got is we have that x minus 3 to the second power, because I'm following order of operations, which means I have to take care of that exponent first. So when I multiply these out, and if you're not sure how to multiply them, you can see previous lessons on multiplying polynomials. But when I multiply these out, I would get x squared minus 6x plus 9. Then to get rid of the parentheses, I have to take that negative 1 that's out front, and I have to distribute it. So when I distribute that negative 1, I'll get negative x squared plus 6x minus 9 plus 1. The last thing to do is to combine like terms. So then that would be negative x squared plus 6x minus 8. And now I've got my equation in standard form. Now there are not many benefits to graphing from standard form, because as you can see, it's a lot easier to graph from vertex form, because we can go through and decode, and it helps us know about the shape and about the shifting that happens to the vertex. Here, it's a little bit more difficult to do that, but what we can do is we can find the vertex. To find the vertex, when it's in standard form, we're going to look for the x-coordinate first. There's a formula. It's negative b over 2a. So going back to the original standard form, we have a, b, and c. So negative 1 is my value of a, 6 is b, negative 8 is c. So when I plug all this in, I would get negative 6 over 2 times negative 1, or negative 6 over negative 2, which is 3. So that's the x-coordinate of my vertex. And now to get the y-coordinate, so now I want to get the vertex y-coordinate, I plug that back in. So my original equation was negative 1 x squared plus 6x minus 8. Now I just put the parentheses in because it helps when you substitute in to have parentheses. But I'm going to plug that 3 right in for x. And I get negative 1 times 9 plus 18 minus 8. That gives me negative 9 plus 18 minus 8, which equals 1. So here's my x-coordinate. Here's my y-coordinate. So my vertex would be 3, 1. And you can see that's what I can see right away from vertex form. So you can figure it out from standard form. It's just a little more hidden and it takes some more steps. But the key to finding the vertex in standard form is this equation right here. Negative b over 2a gives you the x value. Plug that back in and it gives you the y value. And then you have your vertex. And then of course the axis of symmetry is easy to determine because it's just the vertical line that goes through that point. Now one benefit in terms of graphing for the standard form of an equation is that the y-intercept is now very clear. My y-intercept is down here at 0, negative 8, and you can see that right away in my original equation. Once I got it into standard form, the constant term at the end is your y-intercept.